Okay, boys and girls, this is Guided Notes for Unit 3. This is Lesson 4, and in this lesson, we're going to graph a cubic function and determine its features. So, what you're seeing in front of you is considered a cubic function. So, the parent function is a cubic function, and it's given y equals x cubed. Its domain, you're going to like this, its domain is negative infinity to infinity, because if you notice, it just keeps going on and on. So it's negative infinity to infinity, but guess what the range is? Yay! This one is better than the other ones that we did, because the range in a quadratic and absolute value would change depending upon its vertex. But nope, for this one, the range and domain are all negative infinity to infinity. It's an always increasing graph, so going from left to right, it's increasing, so it increases from negative infinity to infinity. The transformation form is like we've seen before, y equals ax minus h cubed plus k. And the h, the h moves left and right, and the k moves up and down, just like we've done before. A cubic function can have as many as 3 solutions. It can have as little as 1, but it will always have at least 1 solution. All cubic functions have at least 1 solution. So I've given you a couple of examples of what cubic functions look like. In this first example, this cubic function has how many zeros? That's right, 3. In this second example, this cubic function has only 1 solution, because it only crosses the x-axis 1. And in this graph, it has 2 solutions. So we transform this just like we've done in the past. So to transform, if I have y equals x minus 3, the transformation that's happening is that it is moving right 3 units. Because remember, the inside does the opposite of what we think. Notice the difference between the first example and the second example. With no parenthesis, and we just have minus 3, that's going to move it down 3 units. And right now, for a normal cubic function, it has a 0 of 0, 0 at the origin. So what would a y equals negative x cubed do? So remember that anytime you have a negative on the outside, that's going to be a reflection about the x-axis. And to give you an example of that, that's what this one looks like. This one was also a reflection. So notice when it's reflected, it becomes an always decreasing function. What does the 2 in front of it will do? It will stretch it vertically. Stretch. All right. How do you spell stretch? Oh, stretch. Stretch. There we go. It's going to stretch it vertically by 2. So that was definitely, so I don't know what I was going to say. So it stretches vertically by 2. This one we have 2 transitions going. It moves it left 4 because of the x plus 4, and then up 1. Okay, we have 3 transformations going. We have a reflection about the axis. We have a move to the right 2, and then an up a 4. So up 4, right 2, and then reflect about the x-axis. So in the next 3 graphs, the next 3 examples, I've given you the graph and I'm asking you what transformation is. So what I want you to remember is what a a cubic function looks like. It's got what we call this little inflection point at 0, 0. So to determine how it moved, we need to look for that little inflection point. So here we see that the inflection point is here. So this graph moved 2 units right, and 1, because this is -2, so this is 1, and 1 unit down. So how could we write the equation for this? So we know that y is equal to x, and because I moved 2 units right, this is going to be x minus 2, and 1 unit down would be minus 1. Okay? All right, so remember our parent function has that little inflection point at 0, 0. So this inflection point is at 4. So what did I do to get from here to here? I moved over to the right 4. I didn't move up or down. So that's simply going to be, so I moved 4 right. And so this is going to be y is equal to x minus 4 cubed. It didn't move up or down, so that's why I don't include anything after it. Okay? So this one did a couple of things. So where is my inflection point? Started here. So now my inflection point is here. So what did I do? I moved 2 to the left and 3 units up. And I did one other thing. Notice that the graph is no longer increasing, it's decreasing on its domain, so therefore I multiplied, I had to reflect it by -1. Reflect it over the x-axis. Reflect over x-axis, okay? Now how do I write that equation? All right, let's start with, I know I reflected over the x-axis, so there's going to be a negative. And then since I moved to the left, this is going to be x plus 2 and 3 units up. And that means that's going to be plus 3. Okay? All right, that's it for cubic functions. And you have a great day.